Here we have another question of limits of accuracy from November 2005, paper 1, question 17. In part A, they are saying a rectangular table top is 100 cm long and 75 cm wide. Both lengths are correct to the nearest 5 cm. So when we divide 5 by 2, it will be 2.5. So to find the upper and the lower bound of the length and width of this rectangular table, we will add and subtract 2.5. Now here they are saying find the least possible perimeter of the table. So first of all, as we know that the perimeter of a rectangle is 2L plus B. It means length plus breadth or length plus width. So here length is given 100 cm and similarly width is 75 cm. To find the perimeter, least possible perimeter, so it means we will find the lower bound of perimeter. To find the lower bound of perimeter, on the right hand side we have a condition of addition. So to find the perimeter, as we have a condition of addition, so we will take the lower bound of both values. So here on the right hand side we will take lower bound of length plus lower bound of width. So to find the lower bound of length, we will subtract 2.5 from 100, and similarly to find the lower bound of width, we will subtract 2.5 from 75. So if we subtracted 100 minus 2.5, so it is 97.5, and similarly when we subtract 2.5 from 75, it will be 72.5. So when we keep these two values here, 97.5 plus 72.5, first we will add these two values and then we will multiply it by 2. So when we get the answer, we will get the lower bound of the perimeter of the rectangular table. When we add 97.5 plus 72.5, it is equal to 170. And when we multiply it by 2, the final answer is 340. So here the lower bound of the perimeter of a rectangular table is 340 centimeter. Now in part B they are saying the area of a rectangular room is 22 meter square, correct to the nearest square meter. So as here we have just 1 because there is no value given here, so it means it's 1, so 1 upon 2 is 0.5. So plus minus 0.5. Now the width is 3 meter, correct to the nearest meter. Again here we have 1, so 1 upon 2 is 0.5. Now find the greatest possible length of the room. So as we know that the area of the rectangular formula is A is equal to length multiplied by width. So as length is area of a rectangular room is given and width is given, we have to find length. So when we shift this width on the left hand side, it will be divided by area. So we will get length. So in this part we have a condition of division. So to find the greatest possible length means we will find the upper bound of length. So to find the upper bound of length, we will take upper bound of area and divided by lower bound of width. Why we are taking upper bound and the lower bound? So to clarify this thing, you should watch my video of limits of accuracy, in which I have explained that in which condition we will do what. So here to find the upper bound of area, we will add 0.5 into 22. So 22 plus 0.5, and to find the lower bound of the width, we will subtract 0.5 from 3. So 3 minus 0.5. So it will be 22.5 divided by 2.5. So when we divide this one, here we will get first 22.5 divided by 2.5, and when we divide it, the final answer is 9. So it means the upper bound of the length of the rectangle is 9 meter. As both values are given in meter, so the unit of length is also meter. So in the first part of the question, we have applied the condition of addition, and in the second part of the question, we have applied the condition of division. I hope you have understood this question. Thank you.